Okay, so I have just started reading data intensive applications, and in here I will be documenting my learning journey. And yeah, here's the first chapter. It talked about non functional programming, uh, the most important three concepts: reliability, scalability, and maintainability. First, what is reliable? Reliability is a system's ability to perform in the same way, or still being able to perform when some bugs or faults happen. Talking about faults, it mentioned the difference between some faults or bugs. That fault is just like a bug or not handling something in your system, a small case. A failure is caused by some bugs, your system, for example, crashing or not responding at all. Handling bugs usually is handled in two ways: fault prevention and tolerance. Prevent, you could easily prevent when your project is at a small scale, uh, but for or at a large scale it's not very applicable. So it's preferable to actually make your system fault tolerant from the start. And as an example, they mentioned the Netflix is Chaos Monkey, which is their way of simulating failure in production. They simply terminate some instance and containers in production so that they can detect their weakness points in the system and solve them before they actually happen. Then, scalability. What is scalability? Scalability is the system's ability to handle load. So, for scalable system usually function or perform in a consistent way regardless of the load. Non-scalable systems usually their performance degrade with high load. Describing load, they mentioned that Twitter is tweet problem. So in Twitter, we have two main operations: the tweet, writing a tweet or tweeting, and reading your timeline. The problem that they faced was, where do we do our expensive work? So we have two strategies. The first one is fan out on read, and the second one is fan out on write. They first started with fan out and read. Usually, when a user opens their timeline, they go and fetch all the tweets from all the people they follow. It's simple, but it makes the reading or the fetching process very slow on read. Then they thought, okay, on average, we have much more read requests, much more than the write requests. So why don't we just add this slowness to the write requests instead, so that when a user opens the app, they would just have a simple, instant experience, and that's what they followed at first or at second. They followed the fan out and write approach, but they had a small problem, which was the celebrities edge case. For users who have many followers, like 2 million followers or 5 millions or more, making a tweet gets very slow. So, to solve such a problem, they followed a hybrid approach. They used the fan out and read for the celebrities. So when a celebrity tweets or make a tweet, it will be instant, and users who follow that celebrity will go get their tweets when they open their timeline. Whereas for normal users, making a tweet will add that tweet to their following list's timeline because they already have too many followers, so it doesn't really get that slow. Then it mentioned the difference between response time and latency. Latency is the time it takes, or the time a request takes till it get processed, or the time for a request waiting to get processed or handled. And the response time is the whole time from the start of like making a request till getting the response back. Then it mentioned how do we measure the performance or the response time of our APIs. It mentioned that we have two ways: the average response time, mentioned in the book as the mean time, and the median. And if we look in here, right here, okay, so the average is not very accurate because simply it sums all the time, or the total time, divided by the total number of requests. So we don't really know, like for example in here, if most of our requests are fast, but like if we have 2 or 3 or 5 requests who are very slow, multiplying the total time, dividing the total time by the total number of requests, it wouldn't really be accurate at all. So it mentioned the median, where we simply sort our response times and take the one in the middle as the average. And by doing that, we know that half of our users had a response time above that average, and half of our users had a response time below that average. Okay, so this is a little bit more accurate. Still, we are not given much or paying much attention to the outliers. So it mentioned that, okay, now we know the median. We have most users had or have a response time in this average, yet we should pay attention to the outliers because they are usually for the most important users. Then it talked about how to cope with load, and it mentioned the difference between scalability and elasticity. Usually, or elasticity is usually when a system increases its resource because it detected a increase in load, or a load increase. So yeah, it's for unpredictable applications. Scalability, you just manually scale up or out because you know that now you have a large or huge load. And it mentioned the difference between scaling up and scaling out. Vertical scaling, horizontal scaling. Scaling up is adding more CPUs or RAM, making your machine more powerful. Scaling out is having many machines. Then it mentioned the trade-offs between them, which is the cost and complexity. Usually the scaling or the horizontal scaling is more complex. And it mentioned that you should usually scale up if you don't really have a problem with cost. You should scale up till you cannot scale up, so you have to scale out. That was the tip from the book at this point. Maintainability, it's very simple. So it is when your system is easy to understand, and to edit, to make edit or changes in it. So when someone new joins, he can easily uh, work on it. And that's it. That's in short was chapter one of data intensive applications.